This is our last step in learning how to multiply any number with the traditional method multiplication. I'm not actually going to show you any new strategies, but just how to extend your patterns from before to any size number. If you have not watched lesson 2, I suggest you do so first before watching this. You can either scan this QR code to be taken right to the lesson, or you can search my channel for traditional multiplication lesson 2. Make sure you have your paper and pencil ready so you can follow along and practice with the lesson. Good luck! To continue our learning of traditional multiplication, we are now going to first review when we have let's say a 4-digit number, 4,254, times a 2-digit number, times 25. I set this up by writing my larger number on top, multiplied by the smaller number. Remember, we are aligning our place values. You should have paper and pencil right now to follow along. So what we do is, as before, we start with our ones place in our bottom number and just multiply across. So why don't you go ahead and pause the video now and do this and come back when you're ready to see. I'm going to start solving now. 5 times 4 is 20. Carry my 2. 5 times 5 is 25. And then I need to add the 2 for 27. Again, I'm going to carry my 2. And now I have 5 times 2 is 10, plus 2 is 12. Carry the 1. And my last one of 5 times 4 is 20, plus 1 is 21. I have nowhere to carry this 2 onto, so I drop it down to the bottom. Now keep in mind, if this number were to become even longer, say 10,000s, 100,000s, millions, my process wouldn't change. All I'm doing is I would continue to multiply the 5 across and continue my pattern of solving. Now that we've finished multiplying with the 5, I'm going to cross out all the numbers that I used to carry so I don't accidentally reuse them. Now again, we are going to multiply our 2 across the top. Now we have to remember that this 2 is actually worth 20. And how do we recognize this 2 for being worth 20? We put in our placeholder of 0. And now all I need to do is take my 2 and multiply across the top. So you can pause and do this on your own to come back and check. 2 times 4 would be 8. 2 times 5 is 10, and I'm going to carry my 1. 2 times 2 is 4, plus 1 is 5, and 2 times 4 is 8. I've now multiplied both of my digits, so all I have left is to add. So I get an answer of 106,350. If you're ever slightly off in these digits, keep in mind, perhaps you just made a small fact mistake with one of your multiplication answers in here, or perhaps you were slightly off with one of your additions. So now let's extend this for numbers becoming larger in our problem, and we're going to use this for any multiplication problem, no matter how large the numbers become. So we are going to do 5,562 times 243. And now you can see we have a slight difference because we now have a 3-digit number as our smallest number. And I want you to just follow along and see the slight change in pattern and how we're continuing our pattern so that you can do this even when this smaller number becomes 4 digits or 5 digits or 10 digits. The pattern will just continue to repeat. Same as always, larger number on top, multiplied by my smaller number, ensuring that I keep the place values aligned. So, our first step is the same. As always, we are going to multiply our 3 across the top. 3 times 2 is 6. 3 times 6 is 18. Carry my 1. 3 times 5 is 15. Plus 1 is 16. And 3 times 5 again is 15. Plus 1 is 16. Now that we're finished with the 3, we need to multiply our 4 across the top. Keep in mind that that 4 is actually worth 40, and we put in our placeholder to recognize it as a 40. Same pattern, multiply across. 4 times 2 is 8. 4 times 6 is 24. I forgot one of my important steps. Cross out old placeholders. So again, I'm going to go back. 4 times 6 is 24. There's my 4. Carry my 2. 4 times 5 is 20. Plus 2 is 22. And 4 times 5 is 20 plus 2 is 22. Now, our last step, we need to multiply the 2 across the top. Just the same as all the rest. But let's think about this for a second. This 2, what is it actually worth? It's in the hundreds place. So that 2 is worth 200. So what we need to do is recognize it as being worth 200. So adding a placeholder of 10 only recognizes it as a 20. We need to put in 2 zeros. And now we follow the same exact pattern. Multiply that 2 across the top. I'm going to cross out my old placeholders and get started with my multiplication. 2 times 2 is 4. 2 times 6 is 12. 2 times 5 is 10. Plus 1 is 11. And 2 times 5 is 10. Plus 1 is 11. Last step, just as before, add them all up. So you can see that the pattern just continues. If we were to have another number here, we would have 3 zero placeholders to recognize it for its thousands place. Our numbers are becoming larger. We have more math that we need to do. So we just need to make sure that we're being careful with our math. It's not more difficult, it just opens up more places for small fact mistakes. So we need to take our time with aligning our place values, neatly writing our numbers, and staying on track with the pattern. So we can see we have an answer of 1,351,566. Our last problem we're going to do together, I want you to solve on your own. And then I want you to come back to see me solve and check your work. Go ahead and pause it now. When you come back, I will be solving. So, to start solving, the first thing I need to do is 692 times, that a little bit neater. I always want to make sure I'm running as neat as possible to stay organized. Times 354. Now here, we have 3 digits and 3 digits. That really doesn't matter. All that matters is we follow our pattern of solving. 4 times 2 is 8. 4 times 9 is 36. 4 times 6 is 24. Plus 3 is 27. I'm going to cross out my old placeholders. Recognize the 5 for being a 50. 5 times 2 is 10. 5 times 9 is 45. Plus 1 is 46. And 5 times 6 is 30. Plus 4 is 34. Cross out my old placeholders. And again, now I'm going to recognize this 3 for being a 300. And I can start my multiplication. 3 times 2 is 6. 3 times 9 is 18. And 3 times... Oh, I'm sorry, that's a mistake. It's always good to be careful. 3 times 9 would be 27. And 3 times 6 is 18. Plus 2 is 20. Last step. Add it all up. And you'll have your final answer. So we should get 244,968. Now, a great way that you can practice on your own is you should make up your own problem. Whatever you want, it doesn't matter. Solve the problem. Then take out your calculator and check your work. And you can create unlimited problems to continue practicing.
So now that we've learned the steps for doing traditional multiplication, you may be asking yourself, Mr. Ehrman, why do I even need to bother learning how to use traditional multiplication when I'm already good at lattice or I'm already good at partial products? And that is actually a very good question. And sometimes different methods are good for different reasons. Partial products is actually the best way to be able to solve multiplication mentally. But in my opinion, doing traditional multiplication on a piece of paper for a long problem is going to be the fastest and most efficient method. And even if you're fluent with lattice, once you become fluent with traditional, lattice just can't be done as fast, and you're going to be able to do more problems at a quicker pace and be able to work a little bit faster. So you want to be confident in using one method, but I would suggest you start to try to use traditional as your go-to method when we're doing multiplication.